Welcome to Video 2D. In this video, we're going to discuss parallel lines and the angles created when they are cut by what we call a transversal. So first of all, on the side, I want you to draw your best picture of two parallel lines. And we'll indicate that they're parallel by putting a little pair of arrows on them. And then we're going to slice them with another line. And this line that's slicing them is called a transversal. So I'm going to call this line T, line L, line N. So I have two parallel lines, L running parallel to N, and they're being sliced by a transversal. And you'll notice that in that process, I've created two sets of four angles. I've got a set up on top here, which I'm going to label angle 1, 2, 3, 4. And that's a quad, or a group of four angles. On the next line, I have another group of four angles. And there's relationships between pairs of these angles that are important. So first thing we need to do is give these pairs names. So if you focus on just their groups of four, if they're in the same spot, top right of its clump of four and the top right of its clump of four, we call them corresponding angles. And I want you to write this down. So corresponding angle pairs. And we would have four sets of those. Angle 1 and angle 5 are in the top right. And their relationship is that they're the same measure. You can see that they're the same measure. It's kind of like the top clump of four and the bottom clump of four are identical angles. So these are equal, by the way. Corresponding angles. Let's do this. Let's put underneath the word. Corresponding angles are congruent or have the same measure. Angle 1 and angle 5 are both in the top right. Angle 2 and angle 6 are called corresponding because they're both in the top left. Maybe I'll put them in boxes. That'll make them easier too. Okay, my other pair of corresponding angles would be angle 3, the bottom left, and angle 7, also in the bottom left of its clump of 4. And then I've got angle 4, bottom right, and angle 8. And those are called corresponding angles, and they're all of equal measure. Let's go label angle 1 up there with, it's cracked open more than 90 degrees and quite a bit more. Let's say that's 120 degrees. If that's 120 degrees, so is its corresponding angle. Next, if that's one is 120 degrees, then by the vertical angle theorem, the ones across from each other, angle 3 would be 120 degrees. And same here, angle 7 would also be 120 degrees. So notice four angles kind of on a zigzag have the exact same measure. Next up, we also have angles that are what we call alternate interior, and they are inside the parallel lines. So I've got my parallel line here, got my parallel line here. I have to stay inside them, so angles in here. So my candidates are 3, 4, 5, and 6, but they have to alternate. And what that means is they have to be on opposite sides of the transversal. That happens with angle 4 and angle 6. They're inside the parallel lines, but they are on opposite sides of the transversal. Also happens with angle 3 and angle 5. So there are two pairs of alternate interior angles, and you can see that those are equal as well. They're all 120 in this case. So let's go take a look at another pair. We also have what's called alternate exterior. Similarly, they have to be outside of the parallel lines. So 1, 2, 7, and 8 are on the outsides of the parallel lines. Those are called exterior. And then we have to be on opposite sides of the transversal. So angle 2, right up here, outside of the parallel lines, and angle 8 right here are called alternate exterior. Likewise, so are angle 1 and angle 7. And again, that's supposed to be an angle, by the way. Their measures are congruent. And let's talk about what their measures are up here. If angle 1's 120 degrees and it makes a line with angle 2, and linear pairs are supplementary or add up to 180, then angle 2 has to be 60 degrees. So does angle 4, so does angle 6, and so does angle 8. So you only have 2 possible, and that's getting kind of messy up there, so we'll redraw that when I'm done. The other angle pair that you need to know is what we call same side, or sometimes it's called consecutive, same side interior. And it kind of depends on what kind of a textbooks you use. Sometimes some textbooks will call this consecutive interior. So they have to be inside the parallel lines, but on the same side. So inside the parallel lines are 3, 4, 5, and 6, but the ones on the same side of the transversal would be angle 3 and angle 6. They're both to the left, and angle 4 and angle 5, which are both to the right. These are not congruent. You can see that they add up to 180, so we say they're supplementary, and we're going to write add to 180 degrees. All right. So let's go over to this picture right over here. Scroll a little bit. And let's suppose that I am asked to classify angle X and angle Y. What are these called? They're not corresponding because this is in the bottom right of its clump of 4, and this one's in the top right of its clump of 4. They're not alternate interior because to be alternate interior, we have to switch sides of we have to hop the transversal. These are what we'd call same side or consecutive interior. So I want you to write X and Y. Really, I should use proper notation. Angle X and angle Y, without the angle there, they're points, are what we call consecutive interior, or you can write same side. Whatever you like for that, I don't care. Consecutive interior. Next, what I want you to do on that picture is let's go put a fake angle measure in there. Let's suppose this is 40 degrees. If that's 40 degrees, what's X? You can see it's not 40 degrees. It's obtuse and X is acute. They're supplementary. They have to add up to 180. So this is 140. All the other angles in this picture are either 40 or 140. And here's how you can even go by looks, but vertical angles are congruent, so you're 40. Vertical angles are congruent, so you're 140, right? Next up, next to each other making a line is 140, 140. All the obtuse ones are 140, and all the acute ones are 40. You'll notice that they're congruent on the zigzag. So when you're going and writing those in. So let's go to the next one. If I had to classify these two, there's lots going on in here, but I want to find the 2 parallel lines that are being cut by a transversal that are being referenced by angle Y and angle X. So those are the 2 parallel lines I'm staring at. I'm going to ignore everything else. They are on this transversal, so I'm going to ignore everything else. So I'm going to pretend what I did not put in red is really not on the picture. And I'm going to classify angle X and angle Y. And one's inside and one's outside. So these are what we'd call corresponding angles. Again, look at the clumps of 4, even put them in a box. Bottom right, bottom right. So we'd say X and Y are corresponding angles. If I had to give their measure, let's suppose those are on there like that, and I say this right here is 35. Well, watch. If that's 35, this is 35. These two make a line together, so this would have to be 145, so they add up to 180. This would have to be 145. This clump would have the exact same corresponding angles are congruent, so top right would be 135. This whole piece right here is 145, 35, 145. Again, you'll notice zig, zag. They're the same on the zigzag. All right, so now we're going to use those relationships to find either the angle measure or to find X. But let's say we're going to find the measure of angle 1. I'm going to put a 1 right there. How would I do that? Well, if I'm going to find the measure of angle 1, I need to find the measure of the angle next to it, because that's the one that's got stuff on it. In order to do that, I need to figure out what x is. In order to do that, I need an equation. Well, what's my equation? I really only have two options because remember, when these two parallel lines are cut by a transversal, there's only two relationships that could possibly hold. Either the angles are congruent, going on the zigzag here, or they add up to 180. Every angle pair is either the exact same measure or they add up to 180. I'm right here on a pair of corresponding angles. This one is in the bottom right and the bottom right, kind of like right here, and they are equal. They look equal, so usually looks will serve you very well when you're deciding, do I set them equal or do I have them add up to 180? Has to do one of the two, and these look equal, so my gut would tell me, even if I wasn't sure that they were called corresponding angles, my gut would tell me to set the measures equal. So there I am. I'm going to figure out what x is. I'm going to get it isolated over here on the left-hand side. I get 2x minus 5 is equal to 5. I'm going to add 5 to both sides. I'm going to get 2x is equal to 10. I'm going to divide both sides by 2, and I'm going to get x is equal to 5. But always answer the question posed. I wanted you to find the measure of angle 1. So what I'm going to do up here is I'm going to go find the measure of the angle next to it. The angle next to it is 23 times 5 minus 5. So let's go take a look at what 23 times 5 is. 5, carry the 1, 115, minus 5 is 110 degrees. So this angle next door is 110 degrees. That means there's 4 other angles that are 110 degrees. The one across from it, and it's corresponding, and the one across from it. All the others are supplementary to that one because these two make a line together. So angle 1 is going to be 180 minus 110, or 70 degrees. So the measure of angle 1 is 70 degrees. Remember to use proper notation for that. You wouldn't say angle 1 equals 70 degrees because angle 1 is a picture. In order to replace it with a measure, you need the m in front of it. So let's see if we have any more here. We do. It also says you can force lines to be parallel by forcing the angle pair relationships. What that means is if I were to write my last statement, I would say if two angles are corresponding, then they are congruent. But I can also do what we call the converse of that. If two corresponding angles are congruent, then the lines are parallel. So you're going to force the relationship that has to occur, and that'll force the force the lines to run parallel. So what I'm going to do is I'm going to say, what does question mark have to be in order for these to be parallel? Well, these are same side interior or consecutive interior. Their relationship is they are either congruent or they add up to 180. If you forget, go by looks. They don't look the same measure. The 80 one is an acute angle, and this one right here is popped open more. Or you look on the page before where we said that consecutive interior add up to 180. So if I want those lines to run parallel, I have to have question mark equal 180 minus 80, or 100 degrees. If it's even a little bit off, if that's not 100 degrees, suppose I made it 90 degrees, right? Then I can see that those lines will not run parallel. So I'm forcing them to be parallel by forcing that angle pair relationship. So let's go take a look at the next one. Again, you're going to ignore what you don't need. I need the parallel lines that my angles are adjacent to. I also need the transversal that's cutting them where those angles are. Then I have to look at the relationship between those angles. All right, I've got this one right here. Maybe I forgot already what these are called, but they're in the same spot of their clump of 4. They're both in the top right. They're actually called corresponding angles, and their measures are equal. But if you forget, remember, the angle pairs can only either be equal or they add up to 180. Go by looks. Those are both obtuse. They are both equal. So I'd say 11x minus 2 has to equal 130 degrees. So 11x has to equal 132 degrees. So x has to equal 132 divided by 11. Let's see what that is. 12. So x equals 12. And then if that's all we're going to do is say x equals 12. But suppose you were asked, well, what's this angle measure right here? Well, this one's 130. This one's 130. The one across from it's 130. The one next to it adds up to 180 with it. So we'd be able to do all of those. So we're done. Next worksheet for you, 2.7. Have a good one.